This is Module 3, Lesson 1, Lesson 3.1, and it's about graphs, tables, and charts. Excuse me. This is kind of a long lesson. There's a lot of information here, but it's really just about reading graphs and charts, tables. So let's just get started with bar graphs. They are used to visually represent a relationship between data. They use horizontal or vertical lines, bars, to show relative quantities. Data are grouped into categories or classes. Each category is represented by a bar on the graph. The length of the bar shows the number of items in each category. All right. So this next part, this example, is about reading this bar graph. So it says, which grade intervals had the highest number of scores? Well, let's just look. We got grades of 25 students, frequency of their scores, and grade intervals. So which grade interval had the highest number of scores? This, 75 to 79. That's the grade interval that most people made. Let's say this was a test that 25 students took. Most of them made between a 75 or 79, any one particular score. And then it says, which grade intervals had the lowest number of scores? Well, you've got two here that are at the lowest. So you've got this 60 to 64 and 65 to 69. Those are the two that had the lowest number of scores. If 90 to 99 is a grade of A, so 90 to 99, grade of A, how many A's were there? Well, in this interval we had 5. In this interval we had 2. So that's a total of 5 plus 2 equals 7. It's something you've been doing off and on your whole life. You're going to have uses for this as an adult. Okay, so on to the next section. How to draw a bar graph. And so you know, you won't have to draw one as part of your assignment. You will have to read a few and answer some questions, but you won't have to draw any for our purposes here. But you need to make sure that you write an appropriate title and that you label everything. You labels for the bars and the scales and the intervals should be equally spaced and include the smallest, smallest and largest values. You draw bars to represent the data. Bars should be of uniform width. They should be the same size and should not touch, it says. They can touch. Make additional notes as needed as you're going along. Anything that you think might be confusing when you're drawing a bar graph. So we are going to totally skip this because you're not going to be required to do it, just to read them. And a few questions about bar graphs that you might need to know is that a standard bar graph illustrates the change in magnitude of just one variable. So this bar graph that we had, the only variable changing, was the score, the grade intervals. Okay? A comparative bar graph is used to illustrate two or more related variables. What we call it a component. What's an M? Component. My God, I'm terrible today. Bar graph is used to show that each bar is the total of various components and the components are stacked on top of each other. Stacked. All right, on to line graphs, where we use a single dot to represent height of the data. And when the dots are in place, they are connected by a line. So, for example, we use this line graph to answer questions. I didn't really show dots on here, but this would have been put together by dots. Points along that would have been at 0, 0.1 or whatever there. And then 6 would have had a dot here, and 8 a dot up here, so that you can read the graph. If the film is being developed to a contrast of 0.05, how long must it be developed? Well, here's 0.05 on the contrast, degree of contrast. So when you just draw your line across here, and then you bring it down. So you could say 9 minutes as an estimate, right in between there. If the film is developed for 13 minutes, what is its degree of contrast? Well, 12 to 14, so right in the middle is 13. Just go straight up and come straight across. What's its degree of contrast? 0.7. And you just use this to answer questions. Time is usually on this horizontal line, and then whatever you're comparing for the time is on this vertical line. So the degree of contrast is on the vertical line. And this didn't have a title, but it says regarding developing film. So you could have put film development as the title. All right, and we'll go over these notes again, but we're not going to actually draw a graph. So we make sure that we're writing an appropriate title, which they did not do up there. Make and label the appropriate horizontal and vertical scales, each with equally spaced intervals. Often the horizontal scale represents time. Most of the time, if time is involved, it will be on that horizontal scale. And we use points, like I was doing up here, finding this point, to represent data and to locate data on the graph. And we connect the data points with a line segment, or a smooth curve like the one above. Most of the time, a line graph looks like this. And there is a couple to read in your assignment for this. But most of the time a line graph looks like that. And sometimes it looks like this, a curve. It just steadily goes off and then it flattens out, because no need to develop the film obviously after 18 minutes, because it's just going to flatten out and you're not going to get any more degree of contrast. Okay, so we're not going to do this. We're not going to make this line graph, okay? But if we were, this would go along the bottom, the days of the week, Monday, Tuesday, so on, and this would be our sales. Up the side here, this would be sales. This would be the days. Okay? A line graph may show data that is always increasing. So it may just continually go up. Decreasing, it may go down. On payday, I have more money in my bank account than I do at the end of the month. So that would be a line graph going down. Or it could fluctuate, like the one I drew. It could go up, down, up, down. When they fluctuate, that means that they're sometimes increasing and sometimes decreasing. All right. On to circle graphs. So it says a circle is divided into sections to give a visual picture of how the whole circle is being divided. So how do you draw a circle graph? Well, we're going to worry more about reading it. I'm going to go through this. We're going to read one as we go here, but you make sure always, you see that's number one on everything, to write an appropriate title. Make sure you title it. You're going to find the sum of the values in the data set. And then we're going to represent each value as a fraction, fractional, or a decimal part of the sum of values. And I'll talk about that in a minute. For each fraction or decimal, we find the number of degrees that correspond with that in the sector of the circle to be represented by the fraction or decimal. Okay, we take that fraction or decimal and we multiply it by how many total degrees in a circle? 360 degrees. The sum of the degrees for all sectors should be 360 degrees. Then you can use a compass tool, protractor, to draw a circle, indicate the center and a starting point of the circle, and for each degree value, draw a sector, use a protractor, a measuring instrument for angles to measure the number of degrees for the sector of the circle that represent the value where the first sector ends and the next sector begins. Okay, the last sector should end at the starting point. I'm going to wrap this up with a play circle graph, okay? And we're not doing this. We're not doing all that. You're just going to have to read graphs. So if I've got this graph, this circle graph, I know that's not perfect, but let's say it is today, and I draw this line straight down, I have half of it, right? If I divide it like this, I have 4 equal spaces. So if this was a 90 degree, then I'd have 4 things here that have equal value in the circle graph. But if I had 5 components to the circle graph, and these 2 were equal, and these 3 were equal, do you understand how that's going there? And then if I said, okay, I'm going to put some values to this, so I'm going to put a smaller section here, and I'm going to leave these two guys the same. You just have to kind of look at it, and let's say that we have, this is 180 people, well, so's this. And if this is half of that, this would be 90, and this would be 90. Well, if the two numbers I had left here for the 180 were 150 and 30, do you see how this all might fit together here? 90% is 1/4, or 90 degrees of it is 1/4 of it. 180 degrees is half of it. And you just have to kind of look and see what the percentages are, where you're at. The numbers on your assignments are all given to you, and it's quite obvious what is represented in the circle graph problems that you have to do. So just take your time and reason through this. Okay, guys, good luck.